Hello. I'm going to go over a problem I encountered while teaching a applied calculus course when we're doing double integrals. And this problem illustrates why even when the integral looks easy, we should always sketch out the area or the region of integration. So the problem, first of all, should just indicate where the typeset version of this is. This is a blog called collegemathsteaching.wordpress.com. This is a blog where I do a lot of write a little short things about college teaching. And what I'm doing is I'm talking about this problem. Now, this is the ebook for Larson's Calculus and Applied Approach, 10th edition, section 7.8. Now, in my paperback version, it's number problem 18 of 7.8, but in the ebook, it's number 17. And you see this integral right here, which I'm going to write up on the my pad if you're having trouble seeing it, but there it is right here. And they give an answer of 5 to this integral. So let's go ahead and take a look at this. The integral as it's written down looks something like this. It's 2 to 0. X is 0 to the square root of 1 minus y squared. And the integrand is minus 5xy, since we're integrating with respect to x first and with respect to y. Now, suppose we don't sketch out the region. No, I want to show you what happens. So if we don't sketch the region here, and we just do the calculations formally, well, this is not hard. It's just integrating dx. So we have 0 to 2 here. You integrate x, that's a simple integral, minus 5 over 2 x squared, you know, times y, since that's a constant, going from x equals 0 to x equals 1 minus y squared square root dy. No problems, right? And actually, this first step isn't a problem, because then if we substitute in, we substitute a 0, we get 0. We substitute in, we get this. Now remember, that's going in for x. Then algebraically, there isn't really much going on here. Not yet. There's no problem yet. Now, if you take, this is a principal square root, but then you square it. And remember, x is going to be from 0 to this, and your y is going to start at 0 here. Now, the y value, that's where the issue comes up. That's just going to be 1 minus y squared times y. And this is very routine at this point. So you have y minus y cubed. And getting a little bit sloppy with the algebra here, but the algebra is not the problem. You integrate y, you get y squared over 2 minus y fourth over 4. Evaluated between 0 and 2. Plug in the 2, so 2 squared is 4. 4 divided by 2 is 2. 2 to the fourth is 16. Notice that's a negative 2. And we get a 5. Okay, and as we see here, that's the answer that's given in the ebook. All right. Now, let's just think about this for a second. Let's think about where this x is. Your x started at 0 and it went to this. So your x is then going to be positive. And your y is positive as well. Now, the first thing you notice, and this is a warning sign here, but note let's see. The function that we're integrating, the integran, is negative on the x greater than 0, y greater than 0 quarter plane or quadrant 1. So we integrated a function, a negative function in the standard direction. X moved from left to right, y moved from up to down, and we integrated this. So how can we get the answer be positive? So something went wrong, right? And this is the main thing right here. If you look at the limits of integration, let's just try to do this. Let's try to do the limits of integration. So let's try to sketch. And if we do that, we'll put our y-axis, and here's our x. Now we know that x equal the square root of 1 minus y squared, square both sides. So we know that x squared plus y squared is 1. And we also know that x, the lower limit, is 0. So we're starting here, and we have this part. Now, technically speaking, this could technically go all the way down here, right? But then the y limits, let's just take a look at the y limits. The lower y limit is y equals 0. So if we put y equals 0 here, we necessarily have everything in this other part. But notice this point here is 0, 1. And y equals 2. Oops. That's somewhere up here, isn't it? I mean, it's not drawn to scale. Obviously, 1 and 2, that's a very poor drawing to scale. I'll just save this. Okay, but then what I'll do is I'll give you a little bit of a better drawing right here. Let's just look at this. Yep. And there we go. That is in fact a better view of our region right here, drawn with Desmos. And we can see the x limit gives us this red curve, and it would go all the way down, but then the lower y limit gives you the blue. The upper one is way up here. I don't think so. And just for grins, to really see that this is completely borked, if we try to integrate over the rectangle going all the way to 2, and let's say we now take our x from 0 to 1 and we integrate the same thing, the x dy, this is not bad at all. It's integral over a rectangle, and technically you can just split this up into multiple of integrals, but that's all right. You get minus 5/2 x squared y, evaluate between 0 and 1, 0, 2, and that's just going to be minus 5/2 y. And you get minus 5/4 y squared, evaluate between 0 and 2, and we get negative 5. So if we integrate over this rectangular region here, we get negative 5, which is the negative of the bogus answer here. So now, to give you an idea what's really going on, I'll go ahead and do this from scratch. Go to go to this GeoAlgebra. This is kind of an interesting thing here. And let's just go ahead and draw our cylinder. So there's our red cylinder here. And then let's look at z equals minus 5xy. Now this is kind of weird how it goes, but the graph is we'll look at it from the top down, maybe with a little bit of aspect. And then we can look at our y equals 0 plane. And look at our x equals 0 plane. So we can now see the planes come into view here. So we have the y equals 0 plane, the x equals 0 plane, which is seen as edge on. So you can see that, you can see that. Then if we try our y equals 2 plane, we can see this y equals 2 plane is nowhere near the cylinder. So so basically the region is completely bogus. So this is a short example of why you really need to sketch a region when you do one of these problems, and why you need to pay attention. Now, a fun exercise would be, well, when we got the positive 5, what the heck did that integral really represent? And sort of fun to ponder that question. So thanks for watching.